Okay, question one here. How does the biochip work in the body? Well, it doesn't. It doesn't really work in the body at all. It's just inert device. So it's coated in biocompatible glass. It's a couple different kinds of glass that can be used, but essentially it just goes in the body and doesn't do anything. That's the whole point, is so that it's secure in the body, but it doesn't really interact with the body. There are other devices in the future that might be developed that could interact with the body in some way, but I mean, even pacemakers, cochlear implants, these things are way more interactive with the body than what we're developing. Um, so, yeah, it doesn't. Question two, what are the main benefits of the technology? What are the bad points? The main benefits are that you upgrade your capabilities as a human being. You are able to talk to machines through magnetic coupling. You can, with the VivoKey prototype that I have here, and we're going to be releasing soon, you'll be able to do cryptography in the body, so like actually encrypt, decrypt data, perform Bitcoin transactions, blockchain signatures, like payments, maybe national identification. Who knows? There's with the power of cryptography, there's a lot of applications that can be opened up. So, yeah, those the benefits are. Essentially, that you can tie your biological identity to your digital identity in a secure way that's inside of you, controlled by you. It's not controlled by a third party. It's not part of a cloud service or anything like that. It's literally your chip. You own it. You put the software on it. It's yours. Bad points? There are none. I mean, honestly. When you're putting something in the body, there's always a risk of infection, but I mean, the risk of infection is even less than an ear piercing, and that, we let infants get ear piercings. So, the reality is the impact of the body is negligible, almost non-existent. The risk of infection is extremely, extremely low. The question is, why wouldn't you? There really are no bad points. Question three, what are the impacts of the chip on daily life of its users? For me, for example, I haven't had to worry about my house keys or my car keys or my computer logon for the last 12 years. We all have these things that we manage in a day, our keys, wallet, and phone, and I've gotten rid of 1/3 of that management burden. And it's not just the days that I forget my keys; it's the days that all the other days that I have to manage them. When I get up to leave the house, I have to check for my keys. When I'm getting up from eating in a restaurant, I have to look for my keys, make sure that I have them. I have to manage them constantly, and that burden is gone. And so with the VivoKey, what I hope to do is move beyond just key replacement and actually replace my wallet as well. So now I'll just be down to my smartphone kind of thing. The idea is that I can relieve that management burden and also have the peace of mind that I have my cryptographically secure identity, tokens, and capabilities with me at all times. I can never forget it. I can't lose it. It's extremely, extremely difficult to steal. People's morbid minds automatically go to cutting off arms and shit like that. But the reality is, it's ridiculous. Billions of iPhones and smart devices are secured with a fingerprint, and nobody's cutting off fingers. So it's just a categorically order of magnitude different kind of crime to kind of dismember a person for their identity. It just doesn't happen. Question 4, are there different types of biochips? If so, which ones? There's different kinds of chips that are implantable. Essentially, we have our X series, which is comprised of mostly our XEM and XNT. Our XEM is a low-frequency ATA5577 chip, which is able to talk to EM systems, electromicronics, HID systems, and DALA systems. There's very few standards in the low-frequency range, so we try to get a chip that could be programmed to work with as many kind of de facto standards as possible. In the high-frequency range, we have our XNT, which is ISO 14438. It's an ISO standard. It's also NFC Type 2 compliant, so it works with a bunch of different systems, as many as possible. We try to make things that are compatible with as many possible systems that we can. But in essence, the application is identity. Those chips have an identifier. They might have some extra memory for storing user data, but by and large, the idea is identity. There might be other things, like I can store my business card on my NFC implant. I can store a YouTube URL or some other kind of data, usually cloud connected or something that points to something on the web. But by and large, the application is just identity-based. The Vivo key is a whole order of magnitude different. It's a cryptographic platform. You can load Java card, smart card apps onto it. You can write your own apps. You can deploy standard apps that we make and provide. You can do a Bitcoin wallet. You can do a ton of different things on the Vivo key platform because it is a platform. It's a computing platform that you can load apps on, which is fundamentally different than just a chip that has an identifier or a little bit of memory space you can read and write to or from. So, just different. So we're trying to improve things all the time and come out with better and better things. Question 5: what is the cost to the company and the user? The company. I'm assuming you mean like a company that might buy a bunch of implants or want to implement an implant-based security system or something. That just depends on what systems they want to integrate and who they choose for their integrator and all that. For the user or the end user who buys the product, we have our XNT is $100 US. If you're going to buy a bulk of them, we could probably get a wholesale discount or something. Like a company wanted to buy 1,000 of them, we could get a discount together for that. But their XCM is, I think, $57, $60 for the kit, that kind of thing. So the costs just range depending on what you want to get. But ultimately, it's extremely low cost. I mean, if you think about getting a tattoo can cost anywhere from $300 to $1,000. This is a highly functional device that's less risky than an ear piercing, and once it's in, you kind of forget about it. You don't manage it. You don't think about it. It doesn't impact your daily life at all unless you want to use it. So, again, the question comes down to why wouldn't you? 6. What are the prerequisites to implant a biochip? You have to be healthy. You don't want to get a piercing when you're sick. You don't want to get a tattoo when you're sick. You don't want to get a surgical procedure when you're sick. So, be healthy. Be of age or able to get parental consent. And probably be, have a place to put it. So other than that, I mean, there really are none. But do your research and be comfortable that you know what you're getting into and what you want to use it for, and you're getting the correct chip, that kind of thing. 7. How is the injection process? It's very straightforward and simple. It takes seconds. Essentially, we prep the skin area, we tent the skin up, and a needle procedure will place the device. So a needle goes in, retract it a bit, eject the chip out of the end of the needle, and remove the needle, bandage, you're good to go. The next day, 24 hours later, you can be washing your hands, taking a shower. It's pretty good. So it's really low impact. I've never really had anybody have an issue with it. And I've personally installed probably close to 2,000 of them at this point over the last few years. Number 8, in which countries is this technology available? All countries that we can ship to. Just go to dangerousthings.com and buy it. We'll ship it to you. We also have partners, professional body piercers who are familiar with skin, aseptic procedure, needlework. We have partners that are signed up all over the world. If there's no partner in your area, we have a guide for how to approach a professional, either a professional piercer or a doctor or a veterinarian or a nurse or anybody who's medically inclined or trained can handle a needle and follow directions. The technology industry already joining the market for biochips. I mean, we're a technology company and we're an industry, and so I would say yes. But if you mean at large, many large companies have bought our products, purchased by the purchasing departments of those companies, not just employees in the company. So I would say it's being looked at, but I have no idea what their plans are. Let's see. Number 10, how does the creation process of biochip work? We define a thing that we want to do, like I want to be able to do cryptography in the body, for example. We identify some partners that might be necessary for achieving that goal. We select a chip and design some prototypes, test them, and make betas and prototypes, and then do a beta, and then release it to the public. So it's pretty much like any product design cycle, except because we're not making medical devices, we don't need to get FDA approval or medical board health approval for any of the devices, just like body jewelry is not approved. So we don't have to go through these long cycles to be able to get approval. And so the thing about FDA approval, which is interesting, is that it only applies to medical devices, which this is not, so we don't need approval. But the other thing that's interesting is that FDA approval is really only needed if you're a device maker that wants to be ensured that your device can be used and paid for by medical insurance companies and have that all fit into this system of healthcare correctly. So a doctor could, at their own discretion, say, I want this patient to use this device. It's not a FDA approved device, but I want them to use it. That's totally legal and within the bounds of a doctor's purview. They can say that and do that, but that puts them at risk for liability because their liability insurance provider, their coverage, will say, "Ooh, you used a non-approved device. You're able to do that as a doctor. You're allowed, but we wouldn't cover you if there was a liability issue." So they put themselves at risk and their practice at risk. Insurance companies will not pay for it, so the patient would have to pay for it out of pocket. So that's another hurdle. So there's all these financial and not necessarily legal hurdles, but again, financial hurdles, either insurance companies for the patient or insurance companies for the doctor, that essentially create these giant hurdles for companies that want to release medical devices pre-approved. So, and then there's something called pre-market pre-market evaluation or pre-market application. Anyway, there's some other things legally speaking, but in essence, we can sidestep that and just release it as a non-medical device, elective device, and it's fine. Let's see, 11. What are the biggest difficulties faced by the company in this area? So our biggest difficulty is dealing with low quantity volumes and developing new techniques. It's a very niche market, so cash flow is very tight. There's no room for error, really. If you spend a bunch of money trying to develop something and fail, that can tank your company. It can put it in bankruptcy or put it in extreme debt or whatever. But because the number of people around the world that are buying this is very small, you don't have a lot of room to try a bunch of things in the R&D space with money. So you have to get creative. You have to be kind of hackery about it, find other solutions, work with people. It can be messy, but when you're ready to do something like manufacturing, usually economies of scale matter. So, if I want to buy 1 billion chips and make 1 billion of these things over the next 12 months, I can do so at a very reasonable price. But because maybe a few thousand people might want to get one over the next 6 months, how do I properly, approach manufacturers and vendors for parts when minimum order quantity for certain parts is 100,000 units and I only need 2,000 or 5,000? It's tough. It's a tough thing. So you have to work partnerships and try to jump in with people to get things done in creative ways. And it's just it's a challenge. It's a lot more challenging when you're working with these very low quantity type manufacturing projects. Number 12, does the company export the technology to other countries? How does this partnership work? Yeah, we just export it. We ship it direct. It's very simple. We kit them here in the U.S. And we do some small batch production here in the U.S. as well on some prototype devices. Our Flex line is all batch produced here. So it's just a matter of shipping. That's it. We do have some distributors that we're trying to work with. So we have a distributor in Germany called Digiwell. We're trying to work on a distributorship in Brazil, but there's been problems in certain areas. But essentially, it just works like any other distributorship. They buy a quantity, they store it, and they sell it. We have an agreement, that kind of thing. So it's all pretty much straightforward. Let's see. Number 13, is there a professional for the creation of biochips? If so, what are the knowledge needed? Oh, is there a profession for the creation of biochips? I guess so, biomedical engineer. That's, most of those people go and make medical devices. You need a kind of a plethora of knowledge. So being able to get, understanding of both the electronics design, the material science, making sure that your manufacturing techniques are aseptic and clean, and like a ton of different things go into it. But by and large, like a biomedical engineer, if you're going to go to school for something like that, probably biomedical or biodevice engineer would make the most sense. Number 14 is what is the future of biochips? Is there any prediction of when this technology could become available to the majority population of the world? The second part of that question, prediction on when the technology would become available to the majority of the population of the world, it's already available. It's today. You can go to dangerousthings.com and buy it. Anyone in the world, as long as we can ship to your country, you can buy it. So it's already available. But I think the question that you wanted to ask is when it will be in use, like ubiquitous. Everybody is using it actively. That's different than available. So that's a different question, and who knows? Maybe never, maybe 20 years. It really just depends on how applications will evolve that will use the chip. So the chip's already useful in certain situations, but not everybody can use the chip because not everybody can like hack their car to start with the chip. Standard applications matter to drive adoption of certain things. So one of the things we want to work on, for example, is payment. The tap and pay, contactless payment like Apple Pay, Samsung Pay, and you can also get a bank card that you can tap and pay. Riding transit, those are ubiquitous applications. Everybody understands that you can do that, and it's everywhere, or it's a majority of places. So if we had a chip that could actually be used for that application, the application will drive people to consider getting a chip. But until that happens, only people that are able and willing to hack their car or do their own projects, build their own projects and solutions. Those are the people that are going to be interested in the chip because they can make the world around them use the chip. Like my house, is filled with different things now that can use the chip because I've created those solutions. But for the average person, they might not have that ability or even want to do that. So until those applications are there won't be adoption, and that could happen really rapidly, or it could happen never. Payment is one of those applications already there, but the hurdle in getting there to having a payment implant is not technology. I already have the Vivo key can already talk to payment terminals. I can tap it on a payment terminal, it goes beep, and then says, "Oh, no card found." The hurdle there is diving into the banking industry and the payment industry, which is it's really rough. It's a rough industry to try to break into and go, "Hey guys, we got a new idea here." So again, people tend to be the problem, not technology. So I'm hoping that we'll be able to do something interesting and find applications that provide a drive for people to say, okay, well, yeah, I can understand. I'd get a chip because I could use it, to ride in my transit or pay for things or get into my house, do all those things. And, like when you're talking about getting into your home, there are electronic door locks now that you can just buy. And anybody really, if you can use a screwdriver, you can install the lock in your door. It doesn't require cutting or anything like that. So, out of the box, off the shelf solutions, if we can get enough of those things together, I think more people, average people, will be compelled to see the benefits of getting an implant. But until then, the implant could promise to do amazing things. But as long as, if there's still hurdles for the average user to be able to do those amazing things in their life, they won't get it. So, that's the challenge in trying to predict when this is going to happen. It's not really possible. So, all right, those are the answers.